Hello, my name is Greg Crinklaw, and I'm the developer of SkyTools. In this tutorial, we are going to look in detail at the target selection tool. Unlike the other tools, this tool is used by everyone, regardless of the type of imaging you do. This is the starting point. Its purpose is to select target objects that are suitable for your imaging system and your observing location. So what does suitable mean? Well, there's three basic things. One, we're looking for objects that are high in the sky, or at least high enough. Two, we're looking for objects that have a good imaging scale. So we don't generally want to image an extended object that's only 2 pixels across, for instance. We want it to be big and nice looking with lots of detail. And three, we are looking for objects that we can reach a reasonable signal-to-noise ratio in a reasonable amount of time. And of course, what's reasonable is ultimately up to you. This tool is list-based. That means you start with a pre-made target list. Target lists are not entire catalogs. In this case, I have the Messier target list selected, and that is ultimately a list of interesting objects. It's not really an astronomical catalog. An astronomical catalog is something like the sharpless objects or the NGC. Those are very long. So to begin with, we start with a target list, which is a subset of that catalog or multiple catalogs that someone has decided are interesting objects to image. So the way we select a target list is we click here, and we have various folders that are preset, but you can add a new folder if you want. The default folder has the target lists that are shipped with the software. Well, you could add a new folder that was for deep sky objects, or a new folder that was just for comets or asteroids or whatever you want to do, and put target lists within that folder. So right here we have the target lists that are located within the default folder. I'm just going to stick with Messier. We can click this View Edit button, and this tells us the title, but we can also have a description of the target list here, and we can switch which folder it's assigned to just by selecting that. We could also drag it from one folder to another. We're just going to stick with the Messier list at this point. So where do we get target lists? We get target lists from these two controls here. We can add objects manually, or we can obtain them via various tools. So let's go ahead and create a new target list and then add some objects manually. To create a new list, I'm going to go up to the target list selection, go down to New, and I am going to type in the name of my list, new list. Press OK. It's appeared in the default folder, and here's my new list. It's empty. Then I can click on Add Objects, and that brings up the Designation Search tool. Now the Designation Search tool is used to manually add objects to a target list, but it's also the place you go if you ever want to look something up. In fact, it's not just available here, but regardless of what tab you're using, it's also available here, so you can always open it. It has two tabs at the top, two different modes, searching and browsing. And let's look at the browse first. I think a lot of people don't ever even look at this or use it. The way that works is you pick a database, say stars, and then you pick a catalog, which is really not so much an actual catalog, but the designations from a catalog. So I'm going to select SAO, and here are all the stars with SAO designations. And sometimes we reach the bottom of what can be displayed, which is 1,000 at a time here. So I click this button, and now we get the next 1,000 objects. Well, it's sort of a tedious way to look through the catalog, but sometimes it's useful. Oh, and I should add that we can always do this. SAO 1220, 1120, and it searched through the browser list and found it. So let's go back to the search tab, because that's the one that most people are going to use. If you know the designation of your object, you can go ahead and type it in here. Now, if it's a catalog designation, it's like, say, HD 1206, then it is really important that you type in the HD. You can't misspell it, and you really should add a space behind that. So I'm going to just put in HD 12, and it has gone through and found HD 12 and a few other objects that it thinks are similar. But in this case, you're really going to just be looking at the top object in your list. You could also put in a word like Aldebaran. I didn't put the whole thing in, I just put part of it. So it did a fuzzy search and found things that are similar to what I typed. But that only works with common names, not actual catalog designations, at least for the most part. Some catalog designations are made up of names, and so you can fuzzy search for those as well. Once you've found your object by typing it in, then it shows up down here, and you can go ahead and bring up the object information for that object. And there's other information available. In this case, this is a double star, so here are the different stars in that system. I could choose D, and now I have targeted the D component of that double star. So you can target more than just the primary star, Aldebaran. Basic information about it here, the position, magnitude. It has no size. You select the list that you want to add your target object to here, and then you click Add to List, and it showed up in the list up there. So that is the basics of how you add an object to an observing list by hand. There's a lot more to this. That's what the help button here is for. The SkyTools help system is primarily designed as a I'm here, what do I do system. So you're here. If you look at any dialogue and you go, I'm not sure what that is, I'm not sure what this does, you click the help button, and there's going to be fairly extensive help on that particular dialogue. So we can go down here and dig deeper. There's the search tab, and it explains in detail how the search tab works. Don't forget to dig deeper. So that is the quick version of the designation search tool. You type things in, click search. Target lists can also be found on our website. So we go to Get Target List, we go to Browse Skyhound. That brings up this dialog. The target lists available on our website are in different sections. So we have stellar target lists. These are lists related to just stars. Miscellaneous target lists. There are all the dwarf planets. Target lists from handbooks. Right? Sue French's Deep Sky Wonders. We select a folder that we want to put the target list into. Say default. And then we click import.
Operation completed.
And it imports. And now when we go over here, we look, there it is. Okay. One thing to be careful about is you put it into a folder. So be careful which folder you put it into. If you put it into the current or auto-generated list folder or one of the folders you created, it may not appear at first. You might have to go looking for it in that folder. The next way is the database power search. And this is a very powerful tool. I'm going to do a tutorial on it by itself for looking up objects in the SkyTools database. And the SkyTools database is very, very extensive. Pretty much anything you can image is going to be in here. So there are a lot of possibilities as far as creating target lists. I'm just going to randomly do something simple. I'm going to choose galactic deep sky. I'm going to choose planetary nebulae. Here are all the different designations. I could say I only want those that have a Minkowski designation. And well, let's just stop there. I'm going to click search. And all of these planetary nebulae are Minkowski. Well, I could create a Minkowski target list right now. There's only 205 of them. So let's go ahead and do that. So I'm going to click new to create a new target list. I'm going to put in Minkowski. Press OK, and select that list. And then select all the objects, click Add to List. Now we've just created a Minkowski planetary nebulae list. There's a lot more you can do with this, but that's the general idea. We'll save that for a different tutorial. So let's go find our Minkowski list. There it is. I'm going to open that. This sometimes takes a little while to do the calculations. Why is that? That is because there's a lot of calculations to be done. All of these fields have to be filled in. One of the things you notice here is the columns have now gone off to the right. So we can drag this over here to see all those columns, but that's probably more columns than we wanted. And I'm going to show you in a minute how to customize those columns to each target list. But we'll get to that in a moment. There are other ways to get target lists. We can read them from a SkyTools.stx file. Now, where do those come from? Well, let's say I wanted to share this Minkowski target list. I'm really excited about it. I want to send it to a friend who also uses SkyTools. Then I go to Share Target Lists, save as STX file. I select the folder that it's in. It's already pre-selected this target list. And then I click Save File, and it will create a .stx file, probably called minkowski.stx, which I can then send to my friend. I can upload it somewhere, people can download it, and then they can import it using that other function, this one here. Okay. The last way to do it is to read targets from a text file. Now, it's really important to understand that when we do this, we're not reading any information about the object. All we're doing is looking them up in SkyTools. It's just like doing the add objects where you enter things by hand, except that you do more than one at a time. So imagine a target list as a text file, and each individual line has a name of a different object in it. When you read that file, SkyTools will go through, read each individual line, and assign one of the objects from the database to that. So that's the next way to do it. This is also relatively complex. We're not going to go into the details here. Basically, what can happen, though, is that it might not recognize one of the designations. Maybe it's not formatted the way SkyTools like. Maybe it's a designation SkyTools doesn't recognize. And anything that's not recognized will show up down here, and you can go ahead and match it by hand. But normally that doesn't happen. Normally things are pretty straightforward. So that's the last way to get a target list. So next, let's look at the target selection tool itself and some of the controls, and we'll start with the controls at the top. Here's the date for the night that's selected, the imaging system, the location, something about the focal situation, which filter we're using, and what binning we're using. All of these things are going to affect the calculations. So we'll start with the night. I'm going to click on that here. It says date of local evening. Notice I called it the night. The date is the evening of the 25th. So the 25th goes up to midnight, and then it turns into the 26th, which is why it says 25th, 26th up here. But when you enter a date, say the 18th, it's important to remember that is the date for the evening, not the next morning. Up here we have a graphic that tells us very quickly what's going on that night as far as moonlight and sky darkness. We can see that this is the altitude of the moon. That's pretty much full moon. Here's new moon there, much darker, and so forth. We can click tonight, tomorrow, last night, or we can type in a date. If we type in a date, we use the SkyTools date format. And the way that works is we do things as year, month, day, time. And in this case, we're not specifying a time, we're specifying a date, so it's year, month, day. And we do that by typing in the year, the month, and the day. And there we go. Now, why do we do it that way? Why do we force year, month, day? Because then we can truncate 2019, 10. So that is for midnight of October 1st. We could also put in 2019.5, and that's the middle of the year. So that's why we do it that way, so that we can truncate. We're going to just stick with this date we've got there. This is our imaging system. We can select an imaging system that's defined here. If we click this little gear icon that shows up in lots of different places, it opens up the dialog where we set up our imaging systems. So these are all the imaging systems that have been set up. We could go ahead and set up a new one, and then it's going to appear in this list. Next, we have the location. Some imaging systems have a fixed location, and this is going to be grayed out. But in this case, it doesn't have a fixed location. This is a telescope that can be moved around, so we could put it at a different place. Same thing with the gear here. Here's our locations. I could assign it to a different location or create a new location or whatever I wanted to do here, rather than just simply select one from the list. Right here we have our focal configuration. A lot of times this isn't going to change. For most people's telescopes, the only choice is going to be primary focus or autofocal changer. An autofocal changer just means that it's going to automatically select from what's available here. And for most people, that's just going to be primary focus. So this isn't going to do much. In this case, for this telescope, it has a focal reducer and a focal extender, and I can change those in and out during the night. So if I put this in autofocal changer, when it does the calculations, it will automatically select a focal changer that's best to use way over here. And in this case, it chose a focal extender. In that case, it chose primary focus. Now let's keep in mind, we haven't really set this target list up yet, particularly the columns. These things are blank for a reason. We'll get back to that in a little bit. So that's what auto means. And for most people, it's going to just be primary and it'll just stay there. Same thing goes with the filters. We can select a specific filter. It will recalculate the list for that filter. Now all the calculations are done for the luminance filter. If we put it in auto, it will choose the representative filter, which usually means the broadest filter, in which case it's going to choose the luminance, unless the situation requires a narrowband filter. Maybe it is a target object with a very bright emission line and it's an O3 emission line. It might choose to use the O3 filter in that case. So we can put that in auto and it will choose the most appropriate filter. Lastly, we have binning. The selections here were set when you set up your imaging system. You said that it went up to bin times 2. So this works the same way. You can fix it at 2 times binning and it will do the calculation at 2 times binning, or you can set it at auto and it will figure out the best binning for each individual target object. Now, I said we hadn't really done anything with our columns. And the first thing I noticed is that only 31 out of 205 Minkowski objects are being listed here. And yet I don't have this filter enabled and I don't have that filter enabled. What's going on? Well, there must be some filter enabled. It's probably that one. How do we clear all the filters to make sure that everything is displayed? Well, we come over here to the list functions and we select reset filters. And now all 205 objects appear, and this has been reset to any. Sometimes there can be hidden filters. If we right-click on some of the things over here, for instance, sometimes that can produce a filter that isn't obvious. So that reset filters is always a good thing to use if things don't look right. We've got a lot of columns here. In fact, we have way too many columns, and some of them are too wide. So how do we control what columns are displayed? And that's done right here. These are the column configurations that have already been set up. I'm going to select the one for deep sky objects. Now we have a much more manageable group of columns. How do we make our own column scheme or modify a column scheme? Well, we use the gear icon here. And that brings up the scheme settings. If we want to enable the alternate designation column, we click that. and save. And now the alternate ID column has appeared. This is the most commonly used name in our designation hierarchy. And so this is the next most commonly used name. If we want one of the columns to appear somewhere else, we can just hold it and drag it and move it. If we want a column to be wider, we can drag it like this and make it wider. If we want it to be narrower, we can do that. So we can set up the columns any way we want. I'm going to go back and turn off the alternate designation column, and now it's gone. Okay, so we're back to where we were before. If we wanted to create our own column scheme, we would click New, enter a title, and any changes we made here would appear on that column scheme, and then we could apply that column scheme to an individual target list. This column scheme here, Deep Sky Columns, has been permanently assigned to this Minkowski target list. If I open another target list, it may have another set of columns assigned to it. Okay, so each target list can have its own column scheme assigned to it. So we've talked about this a little bit before, and that's the night bar up here. I wanted to talk about it a little bit more in detail. The things that are on this graphic are super useful. The first thing is it simply shades the background depending on the brightness of the sky overhead. Now, why don't other people do that? Because they don't calculate the brightness of the sky overhead. So that's the first thing. SkyTools can do that. So now we know just how bright the sky is as twilight begins. And when the moon comes up here, look at that. It really didn't make it much brighter. That's an important thing to know. So we get that in our graphic. And again, let's go over what these lines are. This golden line is the altitude of the sun. It's set. Oh, look, it's getting dark. Okay. And when it rises, twilight is over. The teal line is the altitude of the moon. So as the moon gets higher and higher and higher in the sky, you can see that the sky is getting slightly brighter. The red dashed line is the altitude of our target object. This probably isn't a real good night to observe this target object because it's high in the sky at 3 in the afternoon, right? And, you know, once it gets dark, it's below 2 air mass. I said it's below 2 air mass. That's this green line here. 2 times as much air as over the top. And I should point out that this is an altitude scale. So we're at 75 degrees and we're at 90 degrees at the top. So this is 2 air mass. This second green line is 1.5 air mass, which is something that I often put in here as a constraint. You probably want to do all of your observations above this second green line, if not higher. And finally, we have the blue IQ line. I've touched on that before, and I talk about it in different tutorials, but that is the most critical thing for imaging. You want to do your imaging when this line is as high as possible. Why is it going down? Well, because our object is setting. Why is it near the top, right at the end of twilight? Because our object is too low. Still, all things considered, it's pretty high considering how low in the sky that thing is. But you want to consider other things. If an object is that low in the sky, your stars are going to be smeared from seeing and so forth, even on a good night. It's just plain too low in the sky. And SkyTools will take that sort of thing into account. Let's talk about the weather. This is the weather section. I'm going to check auto here. It's immediately gone and calculated because these settings have changed. This is the seeing. And if I am planning for tonight and I have looked at the weather and it looks like it's going to be a very good night, I can set that to good seeing. If I know what the temperature is going to be, I can put that value in. Let's say it's going to be 10 degrees Fahrenheit. We put in F. We could put in a C as well. And we can enter the relative humidity. So it's going to be pretty good tonight. It's going to be just 20%. Go ahead and it's recalculating again. So now it's recalculated all these numbers here for a seeing of 1.25 arc seconds. What does that mean? That's a full width of half max, at half max of your star profiles of 1.25 arc seconds overhead, not down near the horizon, but overhead. And it's going to be 10 degrees Fahrenheit and 20% humidity. Now, these numbers don't have to be exact. Obviously, the temperature is going to change throughout the night, but this is sort of what we're generally going to expect, and that's really all we need to do our planning. But what if I'm planning for next July? I don't know what, or even next week, I don't know what the temperature and humidity are going to be. I can probably guess in July it's going to be warmer, and our seeing isn't usually as good. So that's why when we set up our location, we set the weather on a monthly basis, right? Well, this one hasn't really been set up. They're all the same. But we can put in the mean weather at night, air temperature, and humidity, and what the typical seeing is year-round. And that, when we click auto, is what it's going to use. So since we are in April, these are the typical temperature and humidity in April, and this is the typical seeing year-round. So that's how the weather works. Let's look at some of these constraints here. General constraints, moon separation. SkyTools considers the moon separation in all of its calculations in detail because it uses that to determine the brightness of the sky background when you take your image. So why do we need this? Well, the thing is, there's more to the sky background from the moonlight than just the brightness of the sky itself. What happens is moonlight gets down into the tube and starts bouncing around, and most people find that there's a minimum distance they can get to the moon before there's too much stray light and they really can't image. So that's the value you want to put in here. I've got 60 degrees. Some people will want to go even closer to the moon. And what this means is if the moon is closer than 60 degrees, SkyTools turns it off and says, you can't observe it. You're going to get this kind of thing. You're going to get dashes for all of the values on that specific night. Maximum number of tiles. Sometimes people are a little surprised at that I use the word tiles. Well, we're making a mosaic, and mosaics are made out of tiles. And I wanted to have a very consistent scheme of the words that are used to describe things. So we're using tiles. So this is 2x2 tiles, 3x3 tiles. And what we're doing here is we're saying that if I set it to that, then it has to fit into a single frame. And if it doesn't, you're going to get a dash like this. If I'm okay with the 2x2 frames, then I can say that. And if I don't care, I can say any. So these are sort of filters applied universally. This one on a specific night, this one any time of the year. We have our prime time of year constraints, and we sort of went over those a little bit. Those are related to these filters and these columns. So this is the maximum air mass that we want to do our observations at. Well, that's 2. No, we can do much better than that. I'm going to say we only want things that are above 1.2 air mass. And look at that, it wiped out all sorts of objects. So we're going to go for only those that are really high in the sky. Remember, 1 air mass is directly overhead. And we only want target objects that can reach a signal-to-noise ratio of 60. Let's go for a high here. And I'm going to enable these filters. And so now, by enabling these filters, what we're saying is that it has to reach a target signal-to-noise ratio of 60 within 60 minutes. Okay? And it has to be above 1.2 air mass for at least 60 minutes. And that has narrowed our list down of 205 objects to just 10 remaining objects. And this doesn't depend on the time of night. These green columns here and these filters here are really a function of your imaging system and your location. So these are really prime objects here. Now let's narrow it down for a specific night. So we come to these columns and these filters, and I'm going to just go ahead and turn them on. Well, everything went away. So what we're saying is, in addition to these filters, on this specific night, these objects have to have an IQ of A for at least 20 minutes. And remember that IQ is this blue line, so it has to be up near the top for at least 20 minutes. And none of these objects met that criteria. So let's drop it down to B. Aha. So now we get some with a B. 30 minutes, 85 minutes, 50 minutes, that's 20 minutes or more. So these are really our prime objects. And at this point, since we have so many columns on, I'm going to go ahead and switch this to the deep sky columns and get us back to a reasonable number of columns. Now we can see that these are our best objects to use. And that's the whole point. This filter determined the best object, most suitable target objects for this imaging system. This filter determined the most suitable target objects for this night. All right, that's a lot, but we are almost done. Let's talk about a couple other things we can do here. Let's look at the list functions menu. We can refresh the list, and that just means it'll go ahead and recalculate everything. Every once in a while, it gets a little wonky, it gets a little off, and the numbers don't look right. And maybe that's because we just downloaded the list or whatever. We click refresh list, and then we're sure that everything's been recalculated. We already saw resetting the filters, and in this case, we can delete the list. I don't think we want to do that. Well, that brings up a question. What if we wanted to delete an object from this list? Let's go ahead and turn off the filters. Now all the objects are back, all 205. See, I really didn't like this one. I'm going to right click on it and select delete, and that will delete it. I could also create an imaging project for it if I actually liked it. I can edit an imaging project if it has one. I can bring up the object information. I can bring up the exposure calculator. This has all sorts of options here. That's a different tutorial. What else can we do? We can view it in the interactive atlas. There we are. Zoom into it. It's small. Looks like it's got a bright star at the center. We can view it on any of the other charts. We can print a chart for it directly. We can get a digital sky survey image for it. We can copy it to a different target list. Click copy to, we select the folder and the list, and it will go off to that other list. Or we could move it, in which case it will be deleted from this list and moved to the other one. We already talked about deleting it. That's all based on a right click. Now, some of these columns do their own thing for a right click, so you can't right click on just any column. But what if I wanted to do things to more than one object at a time? What if I wanted to move 10 objects to a different target list or delete 10 objects or whatever? And that's where this multiple operations column comes in. I can check certain objects, right? Okay, those are the ones I'm going to operate on. I right click in this column. It doesn't even have to be on a check. And now we get things that apply to those 4 checked objects. I can view an overhead sky chart. Okay. These are each of the objects I checked, right? That's kind of a useful thing to do. And I could get deep sky survey images for all of them, or I could copy them all to another list or move them or even delete them all. And what if I wanted to select a block of objects? So I have just sorted by constellation. So what if I wanted to do all of these, all the ones in Aquila? So I would click on the first one, I'd go down to the last one, and I would hold down the shift key and click, and it fills in all the check marks. So now we can copy only those in the constellation Aquila. I can also right click on the top here of the column, and I can check all of them. I can check only the ones that are displayed. Why would I want to check only the ones that are displayed? Well, let's apply filters. Let's say I wanted to move these 4 to a different target list of, maybe I'm building a master target list of really good objects of different types. I could just then right click and copy them to it. And we'll go ahead and clear them. So that's how multiple operations are done. And really the only thing left is to talk about sorting. So we can sort by column just by clicking on the top. That sorts in designation order. By constellation, if I click again, it resorts in the reverse order. Magnitude low to high numbers, high numbers to low numbers, so forth. So anything can be sorted. There's no subsorting yet. That's something that I'm working on. It's harder to do than most people think, because actually aren't that many columns that you would want to subsort on. A lot of these things are continuously variable, and that doesn't work well for subsorting. But that's the general idea of sorting. Most things don't have a right click at the top. I'm right clicking, but some things do. And I think that pretty much covers the details of this whole thing. You can always press the help button. And there's the target selection tool help, and it goes into detail on each of the different things. So that's the target selection tool. Hopefully that helps you understand the details of how to use it. And thanks for watching.